Hi, in this video I'm going to be working through the review problems on the review sheet for test number 1, covering chapters 1, 2, and 3. Number 1, if someone says that the average ballpoint pen has blue ink, what kind of measure of central tendency could they be talking about? Well, usually when people say average, they mean the mean. But that doesn't really make sense here because the variable is qualitative. It's the color of the ink. And you can't calculate the mean of something like that. You can't add together a bunch of ink colors and divide by how many there are. So the only thing that really makes sense here is the most common ink color is blue. And the most common value of a variable, the one that occurs most often, is the mode. Number 2, in each case, tell whether the level of measurement is ratio, interval, ordinal, or nominal. Remember what those mean. Ratio level of measurement is where you're dealing with something that's a number, starting at 0 if there's nothing at all and going up from there. Interval is also a number, but it doesn't start at 0. If there is a value of 0, it doesn't really represent nothing of that thing. It's just sort of a point on the scale. Ordinal is not a number, but there is still an order involved. The different possible values do go in a particular order. Notice the relationship between the word ordinal and the word order. And then nominal is related to the word name. So the nominal level of measurement is you have a name for each possible value, but there isn't an order or a number associated with it. So which one of those would we be dealing with for a student's declared major? The student is a exercise science major. The student is a criminal justice major or whatever. That would be nominal. What about number of credit hours completed? That would be ratio. That is a number. And if that number is 0, that really does mean no credit hours. And somebody who's got 50 credit hours completed, that really is twice as much as somebody who has 25, because 50 is twice as much as 25. So that is the ratio level of measurement. What about a student's class, whether a student is a freshman, sophomore, junior, or senior? Those aren't numbers, but there is a specific order involved, so that would be ordinal. Ordinal as in order. Number 3, here we're trying to decide whether each of these is qualitative or quantitative. A qualitative variable is one that is a quality. A quantitative variable is one that is a quantity. It's a number or an amount. So what about a baseball player's position? Pitcher, catcher, second baseman, or whatever. Is that a number? No. That would just be which one of those things it is, so it's qualitative. And yeah, I know that sometimes numbers are used to refer to specific baseball positions, but those are just sort of identifying labels. You don't do calculations with them. They don't tell you how much of something there is. What about a baseball player's height? Now that would be quantitative. That is a number and it does tell you how much of something there is. In this case, how tall the baseball player is. How about the number of home runs a baseball player has hit in the current season? Quantitative. Again, that is a number, a quantity. How many of something there is. And what about the number of years a baseball player has been on a team? Also quantitative. Now we're deciding whether these are discrete or continuous variables. So remember the difference here. Discrete means you're counting how many of something there are. So it has to be a whole number. Continuous means you're measuring how much, how long, how far, and that doesn't necessarily have to be a whole number. So what about the amount of water in an aquarium? It does not necessarily have to be a whole number of gallons or liters or whatever. You're measuring how much there is. That's a continuous variable. What about the weight of an aquarium? That's also continuous. What about the number of fish in an aquarium? Well, that does have to be a whole number, either 1 or 2 or 20 or whatever, but it can't be something like 3.6. You're counting how many of something there are, so that is a discrete variable. Number 5, if the median price of all the cars on a used car lot is $69.95, what does that mean? So remember what the median is. It's the number that's in the middle when the numbers are arranged in order. So there's always going to be the same number of data values below the median as there are above the median. And in this case, that means that half the cars cost less than the median, $69.95, and half of them cost more than that. Now, if there were more cars priced at $69.95 than any other price, then $69.95 would be the mode, the most common value. And if $69.95 were halfway between the highest and lowest price, that would make it the mid-range. Number 6, a teacher gave 2 exams, a midterm and a final. On the midterm, the mean score was 82 and the standard deviation was 7.7. While on the final, the mean was 82, same mean, and the standard deviation was 3.1. Smaller standard deviation on the final than on the midterm. So what does this tell us about the difference between the results of the 2 exams? They both had the same mean, same average, but the higher standard deviation on the midterm means that the scores on the midterm varied more than the scores on the final. They were more variable. Maybe the high score was higher and the low score was lower. Another way of putting it is to say that the scores on the final were more consistent than the scores on the midterm. They weren't as varied. They were closer together to one another and to the mean. Number 7, what are the boundaries on 27 inches? Remember, boundaries always end in a digit of 5. And in this case, they would be 26.5 to 27.5 inches. So that's from 26.5 to 27.5. Anything between those two numbers, if you round it to the nearest whole number, would be 27. If you took a test and your score corresponded to the 60th percentile, what would that mean? Does it mean you got 60% of the problems right? No. Does it mean you got 60 points? No. What it means is that your score was higher than 60% of the scores on the test. So the percentile refers to what percent of all the scores or all the data values that are below a particular value. Identify each of the following samples by naming the sampling technique used: cluster, random, stratified, or systematic. Measure the length of time that every 5th person coming into a bank waits for teller service over a period of 2 days. So if you're taking every 5th person, that's your system for deciding who's included in the sample. So that would be systematic sampling. What if you take a sample of 5 zip codes from the Chicago metropolitan region and sample every elementary school from each of the zip code regions that you selected to determine the number of students enrolled in 1st grade in each of the schools? That would be cluster sampling. Those 5 zip codes are your clusters that you are using. And what if you divide the users of a social media website into different age groups and then select a random sample from each age group? Then ask members in the sample about the amount of time they use the site each month. So when you divide your overall population into different groups, and then make sure you include some individuals from each one of those groups in your sample. That would be stratified sampling. Number 10, Professor Hill in the music department kept a list of the number of students visiting his office each week for 2 semesters, 30 weeks. The results were, so here we have this list of 30 numbers, one for each of those 30 weeks. So like the first week, he had 15 students visit him in his office. The next week there were 23, then 17, then 13, then 3, and so on. He wishes to make a frequency table, a grouped frequency distribution, for this set of data with 5 classes. So to fit that all into 5 classes, what should the width of each class be? The procedure we had for figuring that out was, first we look through all the data, find the highest and lowest values. So in this case, the highest number here is 31 and the lowest is 3. So the range would be 31 minus 3, which is 28. So that's how far apart the highest and lowest values are. And then we take that range and divide it by the number of classes we want there to be, and then round up to the next highest whole number. So 28 divided by 5 would be 5.6, rounded up is 6. We would need 6 classes, to get 5 classes, we would need a width of 6 for each class. 6 individual numbers in each class in order to get enough room to fit all these numbers into 5 classes. Next question, what should the class limits be for all the classes? Remember we said that the smallest data value was 3, so we can take that as the starting point for the first class. It can start with 3. And then the next class can start with, remember we said the width was going to be 6. So 3 plus 6 is 9. So the second class will start with 9. Then 9 plus 6 would be 15. So the third class would start with 15. 15 plus 6 is 21. Plus 6 is 27. Now what about the upper limits? If the second class is going to start with 9, the first class would have to end with 8. So it includes the numbers 3, 4, 5, 6, 7, and 8. Notice that's 6 numbers. The second class would end with 14, right before the 15 that the next class starts with. Then 20 and 26. And what's the last one? Well, notice that these go up by 6 each time, so the last one would be 26 plus 6, which is 32. So each class has a width of 6. And every one of these numbers is going to get counted in one of these 5 classes. So the frequency is that count. How many of these numbers there are in each one of the classes. So we got to go through the list of numbers and figure out how many of them are somewhere from 3 to 8, how many of them are somewhere from 9 to 14, and so on. So it turns out there are 10 of them that are between 3 and 8. I have them circled here, so you can see, yeah, there's 10 of these numbers that are somewhere from 3 to 8, so that would be the frequency of that class. Then for the rest of them, 9, 6, 2, and 3. And if you add those all up, they add up to 30, which they should, because I told you there were 30 weeks here, 30 numbers in our list of data. Okay, so that's it for the first 10 problems. I'm going to stop this video here, and then in part 2, I will come back and we will pick up where we left off. And in case you had trouble seeing that bottom row here, it was 27 to 32 for the class limits and 3 for the frequency.